Welcome to today's statistics lecture. Today we're going to be looking at normal distribution and how to use an online calculator to solve normal distribution, probability, and percentile questions. When we have a normal distribution word problem, we're going to be looking for some key words. The first key word we're going to be looking for is the words normally distributed. So what that means, all that's telling us is that our distribution is going to follow this bell-shaped curve. The next thing that I'm going to look for is the mean, and the mean is your average, and it is represented by the symbol mu, and that is going to be the center point of your distribution. The next thing you're going to look for is standard deviation, and that's represented by the symbol sigma, and that just tells you how far away from the center point or from the mean your data points are. So this is going to be 1 standard deviation, 2 standard deviations, 3 standard deviations, and so forth. That's going in the positive direction. It also works in the negative. So this is going to be a negative standard deviation, a negative 2 standard deviations, a negative 3 standard deviations. The distribution for a normal distribution is the random variable x, tilde, n for normal, then the mean, and the standard deviation. So what that tells us is that this distribution is going to change or is dependent upon whatever our mean and our standard deviation is. So if we see on the graph on the right, on our calculator, we see that this is set up for a normal standard distribution, which is where we have a mean of 0 and our standard deviation is 1. And so as you can see on the graph, that means that my mean is going to be at the center point 0, and then each of these x values are going to be 1 standard deviation away. So that's 1, 2, 3, and then on the left is negative 1, minus 2, minus 3. Now, if we change the mean and the standard deviation, that's going to change our distribution. So for our examples, let's go ahead and have a mean of 24 and a standard deviation of 6. So I'm going to go to my calculator. The first thing I want to do when I'm using this calculator is I want to make sure that it is on the normal distribution button is clicked. You'll notice it also has the option to do t-distributions, and we will go over those in a future video. So right now we're working with normal distribution. We're going to go ahead and change our mean value to 24. We're going to change our standard deviation to 6. And right now, this has the, and then I'm going to show you how to do the probabilities and inverse probabilities. But right now, let's go ahead and just click on the calculate button. It is automatically just put in a 0 because we left that blank. And you'll notice that the distribution has changed. So now for this one on my graph, my center value is now 24 because that's my mean, and then each of these distributions are now 6 values apart. So 24 plus 6 is 30. If I subtract 6, I'm going to get 18. So that's all that the standard distribution means, is that you're going to move if I have a standard deviation of 6, then that means that's going to be 6 points is going to be my standard deviation. So you'll notice that we still have the bell-shaped curve, but my numbers on the bottom, these are all marked off in values of the standard deviation that's on that we inputted. If they ask us the question, what is the distribution of x? All they're asking is, what does my graph look like? How is my data spread out, or how am I going to organize my data to show how it's distributed or spread out? So we know that the formula for the distribution of x is random variable x tilde n for normal, the mean, and the standard deviation, because this spread or the distribution of data is dependent on the mean and the standard deviation. So we saw with our first graph, we had a mean of 0 and a standard deviation of 1. So that tells me my distribution of x is going to be the random variable x tilde n for normal, my mean, which was 0, and my standard deviation for 1. On my second graph, my distribution for x is going to be the random variable x tilde n for normal, the mean, which was 24, and the standard deviation for 6. And that just tells us that the distribution of x, this formula is just telling us what are the variables that this distribution is dependent on, or if I change these variables, it's going to change how this distribution or how the spread of my data is going to look like. Before we solve for our probabilities, let's understand how to read this graph. The probabilities are going to be the shaded area under the graph. So if I have an empty graph, that's going to give me a 0% probability. If my graph is completely shaded, that's going to give me a 100% probability. And if my graph is partially full or partially filled, that's going to give me a portion. So if it's halfway full, that's going to be a 50% probability, and on this graph that's going to be represented by a decimal. Along the x-axis is going to be my x values or my z-score values. And that's where we have our mean, our 0, and these are all these values along the x-axis, and they're going to be spaced based on your standard deviation. For the examples that we're going to show, we're going to be using x values, but if your problem gives you a z-score value and wants to solve for a probability, or if it gives you a probability and wants to solve for a z-score, you can use this exactly the same. It's just where you see the x, you're going to replace that with your z-score value. And the numbers along the x-axis, those are either going to be x values or z-scores, whichever that you're solving for, but the way that it's calculated is exactly the same. Now let's look at how to solve some probability questions. Our first question says, what is the probability that x is less than 20? So if we were to graph that, what would we expect? We would expect that for some value 20, we're going to want to know this probability. And so we want to find the probability that x is going to be somewhere between 0 and 20. And so we want to know what is the shaded area. That's going to give me my probability. So that means I'm going to use this first box. I want the probability that x is going to be less than 20. So I'm going to put 20 in my box. Let's use a mean of 24, standard deviation of 6. So I need to go ahead and change those. 24 and 6. I've already got my calculator is normally distributed. I've put in my mean. I've put in my standard deviation. I'm going to put my probability into, I'm going to use this first box because I'm looking for values that of x that are less than 20. Then I hit the calculate button and it's going to give me the graph. The shaded part is going to show me the percentage, and this in red is going to give me my answer. And it's going to give me my percentage written as a decimal point. If I'm going to be rounding them to the 4 digits after the decimal, then my answer is going to be 0.2525. And this is the same as saying that I have a 25.25% probability of finding x, that my x value is going to be somewhere between 0 and 20, or my x is going to be less than 20. You'll notice here on the graph where the purple and the white meet, that's where your 20 value is here on the x-axis, and the shaded part tells me where the probability is that I have solved. And using this graph to be able to visually see that what we calculated matched what we expected, it's going to be in a left tail test. When you have something that is less than, the other types of words you might find are shorter or fewer. So anything in your word problem that tells you that you're looking for something smaller than what the number that they gave you, that tells you that you're going to use this first probability calculation. Our next question says, what is the probability x is greater than 30? So once again, let's draw pictures so that we can look at what are we expecting. We've got some value 30 and we want greater than. So that means we're looking for the numbers 30 and bigger. So we're going to want the shaded area going to the right. So that means we're going to want the values of x that are greater than 30. So I'm going to use this second box, put my 30 in that value. Once again, let's use our example of a mean with 24, standard deviation of 6. I've got it already put in from our last problem, and we've got normal distribution, so all of our values are correct. We're going to hit the calculate button, and we see that it is shaded on the right. Starting at 30 is where our x value is, and then our percentage is the shaded part. So it gave us an answer of 0.15865. Once again, if I'm going to round it to, oops, I did that. I went down instead of up. If I'm going to round it to the nearest 4 digits, that's going to be 0.1587. That's going to be my answer. And that tells me I have a 15.87% probability that my x value with a mean of 24, standard deviation of 6, that my x value will be a number greater 30 or greater. Other words that might also qualify besides greater, it might be the words longer, larger, more. Anything that indicates that we're looking for the value of 30 and greater. Anything bigger, that's going to tell you you're going to use this second probability calculation, and you're going to expect a right-tailed test. Our next problem says, what is the probability x is between 15 and 25? So if I'm going to draw this graph, I'm looking for values between 15 and 25. So I'm wanting to know the area between these two numbers and what is the probability that my x value is I'm going to be able to find an x between these two values. So let's use the mean of 24, standard deviation of 6. We've already got those plugged into our calculator. This time we're looking for a range of values, so we're going to use this third probability calculator. We're going to put in the probability that my x is greater than 15 and less than 25. So it's between these two values. Click on calculate. Oh, and I didn't put any numbers, so it's not going to calculate anything for me. So that's 15 and 25. Click on the calculate. You'll notice we've got a shaded portion with, this is a two-tailed test. The middle portion is going to give me my percentage. It's giving me an answer of 0.49937 rounded to 4 digits is going to give me a 4. So this is going to be my answer. And that tells me my probability is a 49.94% probability that my x value will be between these two numbers, between 15 and 25. So that means this shaded area is a 49.94% probability that my x value is going to be located between those two values. So anytime they give you a range, they're looking for a probability between a range of two numbers, then you're going to use this third probability calculation. To solve for percentile questions, we're going to use the inverse probability on this calculator. So let's look at our first question. It says find the 90th percentile. So what does that mean? If we draw our picture, if we draw our graph, then what that tells us is that we are looking for, or we're given the 90th percentile, which is the same as saying 90%. And we want to find what is that x value that matches right here at this point. What is that value that's going to give me, or the x value that's going to give me a 90th percentile? So to solve that, we're going to use our inverse probability. So we're going to use this second set of calculations. We're looking for the probability of some x value that's going to give me 90%. And we're going to write our number in as a decimal. So I'm going to put 0.90 into my calculator. And we're going to go ahead and we'll use an example of a mean of 24, standard deviation of 6. So we check our calculator. We've got it marked for normal distribution. We've got our mean of 24, standard deviation of 6. Those are typed in. We're going to use our inverse probability where we're looking for the values of x that are going to give me the 90th percentile. So this is going to means that somewhere between x, that x value and less, that's going to give me my 90th percentile. So I'm going to calculate, and we see that it's giving me an answer of 31.6893. So that tells me, this answer in red is telling me this x value right here where the purple and the white meet, that's my x value, and that is going to be the x value that will give me a 90th percentile probability, and the 90th percent probability is this purple shaded area. So this value, this unknown value here, that is 31.6893. Our next problem asks us to find the upper 10%. So if we are to graph that, we are looking at the upper 10% probability, and once again we want to find what is that x value that is going to give me this 10%. And the upper 10% is going to the right. So let's use the same values, a mean of 24, standard deviation of 6. This time we're looking for values that are greater. So we're going to look at the probability that the x values are going to be greater than some number, and that is going to give me 10%. So we're going to use the second probability and type in 0.10, hit calculate. It's shaded to the right just like we would expect, and if you'll notice, it's going to give me the same value that I got before when I was looking for the 90th percentile. So these are opposites. And that's one of the things that you want to pay attention to, is how is your question worded. If it just asks for a percentile, it's going to start at the 0 and go to the right. It's going to be how we solved for the 90th percentile, and that's going to be your top probability. That's going to be the most common that you're going to use. If they specifically ask for the upper 10%, then they're asking for a right-tailed test, and they want you to start at a value and go to the right. And you'll notice that if I hit calculate, the numbers are going to be exactly the same. If I switch to the 90th percentile, it's going to be shaded on the left. If I go to find the upper 10%, it's going to be shaded on the right. But that value that it's oscillating or rotating on, that value, that x value, is exactly the same. So you want to pay attention to how your questions are worded. That's going to help you to know which of these inequalities that you're looking for, and also your graph. Pay attention. It's helpful to draw it out a little bit before so to see if your calculator matches what you would expect. But this also tells you that it gives you some options for which of these probabilities that you're going to use, and you just need to know that these are opposite. And we know that these are opposite because if we're going to add these together, 90 plus 10 equals 100. And if this graph was completely full, that would be 100%. Our next question asks us to solve for the interquartile range, the IQR. So if you remember from when we did the box plots, that the IQR is just the middle 50%. So this is our IQR. And we got that the IQR is the middle 50%, and we get that by taking the third quartile range minus the first quartile. And the third quartile is 75%, and the first quartile is at 25%. So if you'll remember, this is 25%, 50% is our median or middle point, 75%, and our outer edges are 100% and 0%. So when we're solving for the interquartile range, for any other distribution, we're going to do the same setup. We're looking for the middle 50%. So at my mean is my middle number, and I'm looking for my Q1 and my Q3. My Q1 is going to be at 25%, and my Q3 is going to be at 75%. And I'm looking for, what is this middle value? This is going to be my IQR, or my middle 50%. So the way that I solve that is I'm going to need to, so you'll notice on the calculator it doesn't have a range like we did when we were solving for the probabilities. So I need to solve for each of these quartiles separately. So what I'm going to do is I am going to solve for my first quartile, and then my third quartile. I'm going to solve for each of these quartiles, and then I'm going to take the difference. So let's take a look at what are we solving for. So this first one, we want to solve for, here's the median. We want to solve for this lower end. That is going to be my lower 25%. Then I'm going to solve for my Q3, and that's going to be this whole area, and that is 75%. And then I'm going to take the difference of these two. So this is what I'm solving for. So to get my Q1, that's at 25%. So that means I'm going to plug this into my probability formula. I'm going to take the probability of X, and I want to know what value is going to give me, and actually that's not even a question mark, that is my Q1. What value is going to give me my Q1, which is going to be 25%. So I'm going to type in 0.25, calculate, and that tells me that my Q1 value is going to be 19.9531. That's my Q1. Now I'm going to do the same thing, and I'm going to solve for Q3. My Q3 is at 75%. So I'm going to do the same thing, but this time I'm solving for my Q3 and I'm going to plug in 0.75%. So I'm going to change that to 75. And for all of these, we'll use the same mean and standard deviation. So let's write that down. Let's say we're given a mean of 24, standard deviation of 6, so that we're staying consistent with all of the problems that we have solved so far. Let's go ahead and hit the calculate button, and that is going to give me my value of 28.0469. So this is my Q3. So that tells me, so we've got our Q1, which is 19.9531. That's this value right here, and that tells me that 19.9531, that is the X value that I need in order to get my 25%. So between 0 and 19.9531, that whole area under the curve is my first quartile at 25%. My third quartile is right here at 28.0469. So all of the area between 0 and 28.0469, that is going to be 75%, and that is my third quartile. So now I want the IQR, so that is going to be the difference between those two values. So the IQR is going to be the Q3 minus Q1. So I'm just going to plug in those numbers. That's 28.0469. Subtract that from 19.9531. And that is going to give me 8.0938. So that tells me, I think I'm running out of space here. There we go. So that tells me that on my graph here, if I have my Q1, I didn't draw that graph very well. Let's redo that graph. So on my graph, I have my middle value here. That's my M. Then I have my Q3, which is at my 75%. My Q1, which is at 25%. This value in between here, this difference, this is my 50%. That difference between those two values is going to be 8.0938. So my IQR is going to be 8.0938. So that tells me that the values between my Q3 and my Q1, so my Q3 was 28.0469, and my Q1 was 19.9531. That difference is 8.0938. So if you get an IQR problem this is how you're going to solve it. So let's just kind of review this because this problem trips up a lot of people. So when you solve for the IQR, what you're looking for, there's 3 steps to this. So the first thing you need to do is you're going to solve for the first quartile. The first quartile is at 25%. So you're going to plug that into your probability calculator. And that's going to give you this point right here, where you're going to get 25%. Then you're going to solve for your third quartile, which is at 75%. So once again, you're going to use that first percentage, plug in 0.75, and get the value for your Q3. Then you're going to take the difference, and that's going to give you your interquartile range. That's your range. That tells you that there is a range of 8.0838 between your first quartile and your third quartile. Our last problem asks us to find the middle 20%. So this is going to be similar to how we solved for the IQR. Let's look at the graph as to what we're solving for. We want to solve for the middle 20%. So that means we want to find the lower boundary and the upper boundary of what are these two values. That in between, the probability in between is going to be 20%, give us a 20% probability. So let's go ahead and we'll use the same mean and standard deviation that we did before. So the first thing we need to do is we need to figure out our percentages. What are we solving for? So if I take 100% minus 20%, that's going to give me 80%. And then I divide that by 2, give me 40%. So that tells me in this white space, I've got 40% on the lower end and 40% on the upper end. So that tells me my lower boundary is at 40%. And my upper boundary is going to be at 60% because I've got 40% plus 20% is going to give me 60%. So now that I have my percentages, I know what I'm going to solve for. So let's draw the pictures. It's going to be similar to what we did with the interquartile range. I'm going to first solve for my lower 40% so that I can get my lower value. Then I'm going to solve for the upper boundary. So this is 40%, and this is 60%. So I'm going to solve for those two, and then I'm going to take the difference between those. I'm going to take the difference between the upper and the lower is going to give me my middle 20%. So this is what I'm solving for. So let's go ahead and put in my calculations. For my lower, to get that lower boundary, I'm going to get the probability that X is going to be less than my lower boundary, and I'm going to set that equal to 40%. and that is giving me a value of, that tells me my lower value is 22.4799. So this value right here where the purple and the white intersect, that is my lower value, and the shaded area is my lower 40%. Now let's solve for the upper boundary, which is going to be at 60%. So I'm going to change this to 60. Click on calculate, and that is going to give me 25.5201. So once again, right here at the spot where the purple and the white meet, that is the upper boundary for my middle 20%. So now I'm going to take those two numbers. I want to get the middle 20%, and so that is going to take that upper boundary minus the lower boundary, and when I subtract those two values, that gives me 3.0402. So that tells me that the middle 20% equals 3.0402. So this would be the answer to my problem. Now there is a second way to solve this problem. And the second way is going to be very similar. So we're going to start out with our graph, just like what we did before, where we calculated we had 40% on the lower boundary, 40% on the upper boundary, and we wanted to solve for this middle 20%. So because we're solving for a lower and a middle value, and we've got an upper and lower percentage values, then what we can do is we can solve for the lower 40% and then solve for the upper 40%. So if I'm going to do that, the lower value, we're going to solve it exactly like we did before. So this time, I'm going to take my lower value, or to solve for that, we're going to take the probability x is less than my lower value, set that equal to 40%, and then when I plug that in to calculate, that gives me my 22.4799. Now when I'm doing the upper boundary, so remember that if I'm using this first probability, inverse probability, it's always going to give me a left-tailed test because it's going from 0 up to whatever my x value is. So now if I want to do the reverse and do an upper limit, get a right-tailed test, then I'm going to use this other probability. So if I want to get the x upper, I'm going to use, I want all of my x values that are going to be greater than my upper limit. I want to get the upper 40%. So the first one was the lower 40%. Now I'm solving for the upper 40%. And you'll notice it's the same, and this is because just like what we saw with our percentile questions, that if I'm getting the lower 60%, I'm going to have that same value as if I'm getting the upper 40%. Because when I add 60 plus 40, add those together, that's going to give me 100%. So if I'm solving for the upper 40%, I'm going to use the second inverse probability, where I'm solving for values that are greater than my x. If I'm solving for the values that are less than, I'm going to use this first one, and I'm going to get that 60. It's going to go from 0 to my value. But then if you'll notice, my numbers are exactly the same. And then once again, if I want to get the middle 20%, I'm going to take that upper value minus the lower value. And that difference is going to give me my middle 20%. So that gives you two different ways to solve for any time that you have any type of two-tailed distribution, where they want a middle portion of your graph. If you have a middle portion, then what you're looking for is you want these two endpoints. You want your lower boundary and your upper boundary of where those percentages are. And then you can either take the difference of two left-tailed tests, left-tailed percentages, or you can take the difference between the lower percentage and from the upper percentage. Those are going to give you the exact same probabilities. This should be everything you need to know to solve your normal distribution, probability, and percentile type questions. See the links below for additional supports and resources, and the link to the online calculator. Be sure to like and subscribe to get the latest videos from Caz Academy. Thanks for watching, and we'll see you at the next video.